In this video, we are going to look at topic 1.2, or mass spectroscopy of the elements. So the topic says, explain the quantitative relationship between the mass spectrum of an element and the masses of the element's isotopes. So before we can talk about the spectrum, we have to talk about how a mass spec actually works. So we have a diagram here, and we're going to start on the left side. That's where our sample goes in. And so our sample goes in and it first gets heated so that it can vaporize. So your sample is often in a solution. So you want it to be a vapor, you want it to be in a gas state. So it gets vaporized, then it passes through an electron beam. By passing through the electron beam, it allows the positive ions to come through, so it ionizes your particles, so it gives them a charge, okay? And then it moves through an ion accelerating electric field so that the beam is moving very quickly, and then it's next going to pass through a magnetic field. So ions have charges, so how much they are attracted to the magnetic field is going to depend on the weight of the atom or the strength of the charge. So in a sample like this, all the charge is going to be the same. So what's going to determine how much it's attracted to a plate is the mass. So the particles that are the lightest are going to be the most attracted, so they're going to be deflected the most. So those are the least massive, those are the lighter because it's easier for them to move. The more massive ions are going to be attracted to the magnetic field the least, so it's going to be deflected the least. And so then once they're split apart based on mass, then they hit the detector plate. Okay, and then our detector plate looks at the ion beam intensity. So the more intense the beam, the more abundant that particular particle. Okay, so then most often they're translated into relative abundance, and then we can use those values to calculate the weighted average. Okay, so a weighted average is not just your standard average. It's not add them all up, divide by the total. It takes into account what the abundance is. So as a reminder, to calculate your weighted average, you take your percent abundance divided by 100. So you're basically converting it from a percent back into a decimal. And then you're going to multiply it by the mass of that ion. And then you repeat this for each ion. So for this sample, we'd add together 1, 2, 3, 4, 5, because we have 5 different isotopes. Okay, so we take the abundance of the one at 90, which is about 50. 50 divided by 100, we would want to know the actual number if we were calculating it. We take this abundance divided by 100, multiply it by 90. Then we do the one for 91. So we take that percent abundance, divide by 100, multiply by 91. 92, we take that abundance, divide by 100, multiply by 92, so on and so forth. When you add them all up, that's where you get your average. So your average is going to be closer to the one that is the most abundant because it's weighted. That one has the greatest weight in the average. So that's how we can analyze a mass spec of an element to determine what the weighted average is, and then we could use that to determine the identity. If we didn't know what it was, we could compare it to the periodic table. From there, we can do lots of things, any of the normal things that we would do with the average mass of an element.